Good afternoon to all. Myself, Dr. Sanjay Agarwal. I am Associate Professor in Electrical Engineering. I welcome you on behalf of School of Engineering and Technology. As you know, on previous Facebook Live lecture, I have discussed about the solar thermal energy technologies. In that particular lecture, I have discussed solar radiation, radiation characteristic of material, heat transfer characteristic of surface, Kirchhoff's law of radiation, type of solar radiation, and mode of heat transfer. And in solar thermal technologies, I have discussed uh, solar cooker and solar water collector. So today I am going to discuss solar thermal and biomass based energy technologies. As you know, this particular topic comes under the program Certificate in Energy Technology and Management. And the topic that I am going to cover, it comes under the course code OEY 002 Renewable Energy Technologies and their uses. So first of all, we have to understand what are the solar air heater. In this particular topic, that is solar air heater, we will discuss what is a solar air heater, classification of the solar air heater, type of the solar air heater like natural type of solar air heater or forced circulation type of solar air heater, and then we will discuss about what are the different advantages of solar air heater. As name is indicating solar air heater. So what is the meaning of this? That means you are getting some hot air from this device and from where this hot air is coming. That means for input is solar. That means solar energy is converting into hot air. That is called solar air heater. In normally air heater, or you can say blower that you use in your home, that is a blower in which what happens, electrical energy is converted into heat energy. So when electrical energy is converted into heat energy, so you get some hot air. That is a function of a normal blower that you use in your home. In solar air heater, what happens, a solar collector is basically a heat exchanger which absorbs the incident solar radiation, convert it into heat, and finally transfer this heat to a heat removal fluid, and this is also called working fluid for an end use system. If the working fluid is a water, solar collector is called solar water collector or solar water heater. If the working fluid is air, then solar collector will be called solar air collector, or you can say solar air heater. Now we have to know what are the different type of solar air heater. So first type has non-porous absorber in which air stream does not flow through the observer plate. Air may flow above or below the observer plate and above or below the observer plate both. Second type has a porous absorber in which stream flows through the observer plate. Now you can see in the picture that is a non-porous type solar air heater. Here you can see there is one chamber that is denoted as a air flow duct in which air flows, and there is a above the chamber above part is a absorber which has a black surface. Why it is blackened? Because to absorb the more heat. So what happens here, as in incident solar radiation on the blackened surface gets absorbed and the resulting heat is partially transferred to the flowing air within the duct. But the main disadvantage of this type of solar air collector is high thermal losses to the ambient due to the convection and radiation. So you can understand, like, air is coming inside, so the temperature of this air is what? That is the ambient temperature. Means suppose we are talking at this condition, so in this particular room, this ambient temperature may be suppose 28 or 29 degrees centigrade. As air will go inside the duct, this air will come in contact of the base of the absorber, and where heat associated with the base of the absorber will transfer to the working fluid, that is air. Now you can see that is air out. That means you will get some hot air. So there is a difference in the temperature between air out and air in. So there is a difference in temperature. That means you are able to get the heat. and heat is what? Q is equal to mc delta T, and delta T is what? Delta T is nothing but it is a difference in temperature between air out and air in. Now another type you can see here, non-porous type solar air heater with glazing. What is the change in this particular non-porous type solar air heater with glazing? Here you can see absorber is at the below of the particular channel, and at the above top there is a glass cover. Glass cover is nothing but it is, you can say, glazing. So what happens here? Solar radiation comes on the top surface of the glass, and it has a short wavelength radiation which have a high energy, and this energy will transfer to the chamber and at the absorber, because it is a blackened surface, so heat which is coming from in form of the short wave radiation, it will be absorbed by the absorber. Now what will happen? Air will flow above the absorber plate. Again phenomena will be the same. Air will go in the chamber, and this air will come in contact of the absorber, and heat associated at the absorber will be transferred to the air, and then you can collect the hot air. The convective losses can be reduced by covering the absorber plate with one or more transparent cover, usually called glazing. So you can understand like this, there is a one glass cover over, it may be the two glass cover. There will be some advantage and disadvantage, then we will discuss later what is the advantage of one glass cover and what is the advantage of two glass cover. Another type you can see here, non-porous type solar air heater with glazing. Here you can see absorber in between, that means between the glass cover and at the bottom. So here heat will be transferred between the absorber and the between the bottom of this particular chamber. And principle is the same. Again this air will come in contact of the absorber, heat associated with the absorber will transfer to the air, and you can collect the hot air. Hot air is nothing but that is a heat in form Q is equal to mc delta T. Again you can also see this selective coating may be applied to the absorber to reduce the radiative losses. The main problem is the losses. Losses means if you can see here that there is insulation. If this insulation is not proper, that means whatever the heat is collected inside of the chamber, this heat may be transferred to the ambient. So this will be the losses. So to reduce the losses from the chamber to the ambient, you need to use proper insulation so that heat may not be able to transfer to the ambient. Here you can understand the thermal efficiency of solar collector is given by the following relation. Eta is equal to useful heat gain upon input energy. Useful heat gain means you can understand like this. Efficiency is equal to what? Output upon input. And what is output here? Output is nothing but it is a thermal energy. And what is a thermal energy? QU. That is mCp delta T. And delta T is what? TO minus TI. So TO is outlet air temperature and TI is inlet air temperature. Inlet air temperature is what? Inlet air temperature is nothing but it is a ambient temperature. Now what is the input energy? Input energy is solar energy, and solar energy means you can calculate the solar energy like suppose intensity of solar energy is IT, that is unity is watt per meter square, and this particular solar radiation will incident on particular cover of the glass. That means you have to consider that area of particular cover. So input energy is what? IT, that is the solar radiation in watt per meter squared multiplied by the area of that particular cover. So area is area cancelled by, so input is watt. So input energy is what? IT into multiplied by area of that particular cover, and output is what? Q is equal to mc delta T. Again you can understand by this how can you calculate the useful heat delivered by the solar collector. Energy absorbed by the absorber surface of the collector minus heat loss from the absorber to the surrounding. So how much energy is trapped by the solar collector? How can you calculate? Suppose this is a upper glass cover, right? And this is a chamber, and there is a glass cover above the particular chamber. Now what will happen? Heat will come at the on the glass, and this heat will be transferred to the absorber. That means IT multiplied by the transmittivity of the glass, because you are, suppose the transmittivity of glass is 1. If it is a perfect glass, that means it can transmit total solar radiation. Again, and what is alpha? Alpha is what? Absorptivity of the solar cell. That means intensity multiplied by transmittivity and multiplied by absorptivity and multiplied by the area of that particular collector is what? It is a energy absorbed by the absorber surface of the collector. Now this amount of heat has come to the absorber. Now, as I have already discussed, there will be some heat losses, and how the heat losses occurs? Heat losses occurs means, suppose solar radiation comes here, it will be transferred to the ambient, or you can understand heat comes inside of the chamber and some heat will be transferred to the ambient through the body of the chamber or through the insulation. So that losses can be calculated or can be written as UL multiplied by Ti minus Ta, where UL is what? Overall heat transfer coefficient. Overall heat transfer coefficient means what? That means heat may be transferred from the body of the chamber, heat may be transferred from the insulation of the chamber. So all heat transfer coefficient can be denoted as U suffix L, and Ti is what? Ti is nothing but it is a temperature of the working fluid, and Ta is a ambient temperature. So energy absorbed by the absorber surface of the collector is what? Fr multiplied by AC multiplied by intensity multiplied by the tau, that is the transmittivity, and multiplied by the alpha, that is the absorptivity of the collector. Now loss is what? Fr into AC multiplied by U suffix L multiplied by Ti minus Tia. Now this is a thermal energy, because we are talking about the efficiency. So efficiency is equal to what? Output upon input. So just you divide by the input in this formula, that means IT multiplied by AC. So you can see here that AC and I will be cancelled out. So it will be the Fr tau into alpha minus Fr UL Ti minus Ta upon I. This particular equation is known as Hotel-Wheeler-Bliss equation. Here you have to notice that what is a Fr? Fr is nothing but it is a heat removal factor, that is defined as ratio of useful collected energy upon useful collected energy if absorber plate were at the inlet air temperature. Now question arises, because we have talked about the solar air collector. Now you have to increase the efficiency of this particular solar air collector. So by this formula you can easily understand how the efficiency of this particular solar collector can be improved. Here you can see that output is what? Output is MCP TO minus TA. That means this is a output. So if you have to increase the output, because TO and Ti is a fixed, you cannot control, it will be depend on the solar radiation. But this is mass flow rate, that M is nothing but it is a mass flow rate. That means if you are able to increase the mass flow rate of the air, that means you can increase the total thermal energy. And this mass flow rate depends on the different quantity. This M is nothing but it is a product of rho, that is a density of the air, A, area of that particular duct, and V is the velocity of the air, from which velocity air is coming out from the solar collector. That means these three parameters you can, a specific density is fixed, that means you can control only the velocity of the air. If you are able to increase the velocity of the air, that means you can increase the mass flow rate. Another parameter is what? By which you can increase the efficiency of the solar collector, that is Fr. That means if you are able to increase the heat removal factor, that means you can get the more hot air, that in form of the heat. Another factor is what? If you are able to reduce the overall heat transfer coefficient. And how the overall heat transfer coefficient can be reduced? By using the proper insulation. You can decrease this overall heat transfer coefficient. Now another factor is what? Because I told you that if you are using the two layer of the glazing, again you can increase the thermal efficiency. How? Because you are able to reduce the thermal losses from the inside of the chamber to the ambient. But another drawback will be what? Because this value of the tau and alpha will again you have to multiply 2 times tau and alpha. That means this value will be decrease. If this value will be decreased, that means overall heat will be decreased. So this is the how you can increase the thermal efficiency of the solar collector. As I already explained you in detail, the efficiency can be increased by increasing the heat removal factor, increasing the mass flow rate per unit area, increasing the convective heat transfer coefficient between air stream and the absorber plate, by increasing the surface area to transfer heat from the absorber plate to the air stream using fins. So this is how we can increase the thermal efficiency of the solar collector. I am talking about the thermal efficiency only because there is no electrical part here, there is no solar cell, so I am talking about only the thermal efficiency. Here you can notice the number of transparent cover over the absorber is an important factor influencing the collector performance. With increasing number of cover, the overall thermal losses from the absorber plate to ambient decrease. But simultaneously what happens? The effective transmittivity and absorptivity product of the system also decrease. So what you have to do? Because you have to increase the thermal efficiency, that means you have to reduce the overall thermal loss as well as you have to get the more thermal gain. That means there will be some optimization between these two quantities, solar gain and heat loss. So there should be some balance between solar gain and heat loss. Now the use of one or more cover usually depends on the range of the temperature for which the collector is designed. The final selection of the number of cover has to be based on the economic performance criteria, which aims to minimize the life cycle cost of thermal energy collected by solar air heater. Here you can see the non-porous type solar air heater with V corrugation and another is non-porous type solar air heater with fins. The main disadvantage of non-porous solar air heater is the low transfer between the air and the absorber plate, right? The heat transfer can be increased by roughing the surface of the absorber plate at the rear, by the adding the fins or by making the absorber plate be corrugated. Here you can see the air is coming inside of the chamber and there is a cover at the top and there is a B corrugated just below the cover and absorber at the base. So here this air is coming inside of the chamber, heat associated with the absorber is transferred to the air, and due to this B corrugation you are able to reduce the heat transfer coefficient to the ambient. Similarly, number of fins are used. So if you are using number of fins in the air chamber, that means you are able to increase the collector area. If you are able to increase the collector area, that means heat associated at the collector is more, that means you are getting a more thermal energy, and this associated thermal energy will transfer to the working fluid, that is air, and this hot air is coming at the outlet point. So you are getting a more heated air. That means difference in temperature is more. If there is a difference in temperature is more between air and air out, that means more thermal energy you are getting. Now we have to understand what are the drawbacks of the non-porous absorber plate. First is the necessity of absorbing all incoming solar radiation over the projected area from a thin layer over the surface, which is of the order of the few microns. Unless selective coating are used, radiation losses from the absorber plate are excessive and therefore the collection efficiency is difficult to improve. So this is the first drawback. Another drawback is what? The pressure drop along the duct formed between the absorber plate and the rear insulation is also prohibitive in non-porous absorber. Any effort to increase the heat transfer between the absorber and the flowing air stream, such as adding fins or enlarged corrugation, result in increased pressure drop across the collector. So what you have to need? More fan power is therefore required to maintain the same airflow rate through the heater. So these two are the drawback of the non-porous absorber plate. Here you can see solar air collector with a porous absorber plate. A porous absorber overcomes some of the problem in the following way. The solar radiation penetrates to greater depth and is absorbed gradually depending upon the porosity of the absorber. The incoming air introduced from the upper surface of the matrix is first heated by the upper layer. Then the air stream gets heated while traveling through the matrix layer. The lower matrix layer are hotter than the upper ones, resulting into better heat transfer from the matrix. And the pressure drop from the porous matrix is usually much lower than the non-porous absorber. Now you have to understand, we have discussed about the solar air heating system. Now what is the advantage of this solar air heating system? This solar air heating system can be understand, you can use this particular solar air collector for the space heating. You can also use it for the solar drying. That means you can dry the different crops like mint, tulsi, and you can also use solar air collector for the solar water heating system also. And how it can be used for the space heating, we can understand here. Solar air heating system consists of an array of solar air heating collector along with the storage facility, that is a pebble bed. There may be 4 possible modes of operation. First, if the solar radiation is available and the heating load is there, the room air is circulated through the solar collector and returned back to the room. When there is no space heating load, the air heated by the collector is sent through the pebble bed storage, where the thermal energy carried by the hot air is absorbed by the pebble bed for after use. And when there is no sunlight but the space requires heating, the room air is circulated through the pebble bed to meet the required heating load. Now you can see, when there is no sunlight or the stored energy is not sufficient to meet the required heating load, then some auxiliary energy source is used to meet the extra heating demand. So this is how the solar air heater can be used for the space heating. Now another advantage, as I told you, that is a solar water heating system. So most of the solar air heating system designed for space heating also provide the need for domestic hot water requirement by using air or water heat exchanger and a water storage tank. The third is a solar drying. As I told you that it can be used for the crop drying. How it will be used, you can understand by this particular figure. Here you can see in the first block there is a solar collector. The solar radiation comes in the incident, and it incident on the top glass, top cover of the solar collector. This heat is absorbed by the solar collector, and now this heat will be transferred to the air handling unit, and this outlet of this air handling unit will work as an inlet of drying chamber, where you will put the different crop that you want to dry. Now what will happen? This hot air will come in contact of that wetted crop, and what will happen? Some humid will be extracted from the crop. If humid is, you are able to extract the humid, that means you are able to dry the crop and you can collect the dried product output. So this is in brief how the solar drying can be used. We will discuss solar drying in detail in the next lecture. As I told you in starting, there is a 2 type of solar air collector. One is natural type hybrid solar collector, another is a forced type solar air collector. This is another type solar air collector, that is name is denoted hybrid photovoltaic thermal air collector. So because here photovoltaic is also coming, so first of all you can understand there is a no photovoltaic, there is a glass only, and below the glass there is a chamber, air is coming inside the air and you are collecting the hot air. So this phenomena is occurring naturally, that means air is flowing by the natural process, or you can say it is by the thermosiphon process. But you have to increase the yield, that means what you have to need, you have to force the air below the chamber. And to force the air below the chamber, what do you need? You need some fan. If you need a fan, that means you have to operate fan by some auxiliary system. Auxiliary system, and that means because it is electrical fan, that means you need to give some electrical energy to this DC fan. But question is, if there is no electricity at that particular area where you are using the air collector, then how you can operate that particular fan? So this fan can be used by the photovoltaic. That means if you are able to replace all the glazing above the air chamber by the semi-transparent PV module, so what you can do, heat is transferred through the glass of the solar cell to the chamber. That means you are getting the hot air. At the same time, you are getting electrical energy from the PV modules, which will be useful to operate the DC fan. At the same time, this output of these PV modules can be integrated to the room, that is a particular house, that can be used for the switch on the CFL lamp or the fan. Another advantage is what of this solar air collector, because you are extracting heat associated with the base of the PV module. So what you are doing, you are removing the heat from the base of the solar cell. As I discussed in the first lecture, that temperature is also one factor which reduces the electrical efficiency of the solar cell. That means you are reducing the heat associated from the base of the PV module. That means you are able to increase the electrical efficiency of the PV module. That means by such type of system, you are getting a two type of energy. One is electrical energy, another is thermal energy. That's why this type of system is called hybrid photovoltaic thermal air collector. Right? So this is you can also say this is a forced mode air collector. Now another technology that is based on the solar, that is a solar still. Now you have to understand what is the application of solar still. First of all, we have to understand that you know that 79% of the water available on the earth is salty, and only 1% is fresh, and rest is about 20% is brackish water. The consumption of unhygienic water is one of the major reasons for many diseases. It is estimated that about 2 billion people are without adequate access to a safe water supply. Many people travel up to 30 km to collect fresh water, an activity which takes more than 6 hours daily. You can imagine what is the difficulty to get the fresh water everywhere. So solution is what? Solution is solar still. So question arises, what is a solar still? The solar still is nothing but it is a device which converts impure water like brackish or saline water into a pure water. It is a simple technology to get potable or fresh distilled water from impure water using solar energy as a fuel for its various applications in domestic and industrial sector. That means what solar energy is doing. So whatever the energy required to convert impure water to fresh water, that energy is taken from the solar. That's why it is called solar still. Here you can understand the main feature of the solar still. Here you can see the bottom of the basin is usually painted black to absorb solar radiation. Why it is painted by the block? Because it is painted by the black paint. That means absorbability of that absorber is more, and it will be able to collect more thermal energy. And top of the basin is covered with the glass. The glass is tilted so as to allow maximum transition of the solar radiation throughout the day. The tilted glass enables condensed vapor to trickle down into troughs, a built-in channel in the still basin. The edges of the glass are sealed with the tar tape so as to make basin airtight. The entire assembly is placed on a stand structure. The outlet is connected to a storage container through a pipe. Provision is made to change water in the stills. A window is provided in the basin to clean the still basin from the inside. The still is filled with the brackish water in a thin layer. Now you have to understand how solar still work. So here you can see there is a glass cover which is tilted. So what will happen? The solar radiation comes on the glass. It is in the form of the short wave radiation, and this short wave radiation will because it has high energy, so it has so much energy that it can transmit or it can penetrate through the glass, and this solar radiation or heat will be transferred to the absorber, and all the heat will be absorbed by the absorber. That means the temperature of this absorber will be increased. Now this heat associated at the absorber will be transferred to the water. There is a inside the chamber there is a water. That means water will becomes heated. If water becomes heated, that means it will start to evaporate. When water will evaporate, it will go to the glass cover and back side of the glass cover. As this water will reach to the back surface of the glass cover, and glass cover is already temperature of this glass cover is less than the temperature of this water, so latent heat of this evaporated water will be transferred to the glass. That means this total latent heat will be transferred to the glass, and this water vapor will be condensed, and this condensed water will trickle across through the glass, and it will be transferred through the trough, and you can collect at the outlet point. So this is the how solar still work. Now you have to see how the efficiency of this solar radiation will be increased. So here interesting fact you can see here. One is the absorptivity. That means if you are able to increase the absorptivity of the solar cell base of the solar still, that means, or you can reduce the temperature of the glass cover. That means to get the more yield, or you can say to get the more distilled water from this solar still, you have to increase the difference in the temperature. And how the difference in the temperature can be increased? Either you increase the temperature of the evaporated water, or you reduce the temperature of the glass cover. We will discuss later how it can be done. Now you have to understand the classification of the solar still. Basically, solar still is of two types. One is passive, another is active. Passive solar distillation can be classified as conventional solar still, and second is multi-effect solar still. Similarly, active distillation can be classified as high temperature distillation and nocturnal distillation. So this is the classification. Here we have to understand simple double effect solar still. Here you can see there is a double glazing are used here. Now you have to understand what is the advantage of this double glazing. What happens here? Water is allowed to flow through the space of double glazing system, so that evaporation does not take place as in case of open water flow over the glass cover. That means cover is made like this. There is a two glass cover, and there is a space between this glass cover. So there is a air in between. So air, as I explained earlier also, air will work as a insulation. As water comes in the base of the glass cover, so it may be happen that some water may be evaporated. Now what will happen here? The water will flow, receive all latent heat of the condensation from the lower basin, and then gets heated, and finally it is fed into the basin. So whatever the heat is inside of the double glazing or hot air in form of the water, this hot water again can be injected inside of the chamber. If you are able to inject the hot water inside the chamber, that means you are able to increase the temperature of the water. If you are able to increase the temperature of the water of inside of the chamber, that means you are increasing the temperature of the evaporated water. That means evaporation will be more. If evaporation will be more, that means this water will reach to the glass cover of this glazing, and again it will transfer this latent heat to the glazing, and this water will be condensed, and you can collect this distilled water. That means by this mechanism you can increase the yield of solar still. Here is some pictures that is I have taken from IIT Delhi. My guide Professor G.N. Tiwari has worked a lot on this. So here you can see there is a different type of solar still are here. you can see the difference is between the different angle, because you have to aim is what? You have to get the maximum solar radiation, and to get the, what is the aim? To get the maximum solar radiation means you have to get the more heat. To get the more heat means you have to increase the temperature of the water. So here it was observed कि if angle is less, what will be the effect on the yield of the solar steel. So you can see there is a here area of collector is also changing, and angle of this solar the solar distillation is also changing. So this was done to see the effect of the angle and to see the effect of the glass. This is the double slope solar steel. What will be the advantage of this double slope steel? Because if you will put the solar steel toward the south facing of the sun, you will get the maximum solar radiation. Now because sun moves one direction to another direction, so it is useful if solar radiation comes to the another direction, at that time you can also get the some solar radiation. So by this means you can get the some solar radiation of the solar radiation at that time when sun is not at the south. So that means by this technique you can again increase the yield of the water. Now you have to understand the active solar distillation. The daily distilled output of passive solar steel can be increased by increasing the temperature difference between the evaporating and the condensing surface. Such a condition can be achieved either by increasing evaporating surface temperature or by decreasing the condensing surface temperature, or combination of the both. As I told you, that means if you want to increase the yield of the solar steel, that means either you increase the evaporating temperature of the water, either you decrease the condensing temperature of that particular glass, or combination of both can be used. The evaporating surface temperature can be increased by feeding the thermal energy into the basin from an external source, and this can be done as follows. First, the feeding of the hot water into the basin once in a day. Second, by the preheated water application. That means the feeding of the hot water into the basin at constant flow rate. And third is high temperature distillation. That means feeding of the hot water into the basin from the solar collector panel. Here you can see there is a top above, there is a solar steel chamber, and to increase the temperature of the water inside of the chamber, there is a solar collector is used. By what is the use of this solar collector? That means you are giving a hot water inside of the chamber. That means already hot air you are putting inside the chamber. That means you are increasing the temperature of the evaporation water. Now you have to again increase the temperature of this solar distillation. That means you have to force the water. And how you can force the water inside the chamber? By using the pump. That means you have to operate the DC pump. Now question arises, how you will use the DC pump? This DC pump can be operated by the PV module. Here you can see there is in first chamber, below the chamber there is a transparent PV module which is used to operate the DC pump, which will force the water inside of the hot water collector, and this hot water will be transferred to the solar distill. So it will increase the temperature of the evaporative water. So more evaporation will be occur. If more evaporation will be occur, this water will reach to the glass cover of the solar distillation. It will be condensed. That means you can collect the more pure water at the outlet from the solar distillation. Again, this is a two collector were used, and because you have to increase the more yield, that means capacity of the pump was increased. If you are increasing the capacity of that DC pump, that means you require a more DC power. That means two PV modules are used here. So this is again forced type solar distillation. Now what are the advantage of the solar steel? First advantage is it produces pure water, no prime mover required, no conventional energy required because you are using the solar energy which is free, no skilled operator required, local manufacturing and repairing is possible, and there is a low investment in this solar steel. Now we are coming the another technology, that is a biomass based energy technologies. The people in India make use all possible energy resources like solar energy, wind energy, and biomass energy. So we are focusing here on the biomass energy. The biomass contributes to about 14% of the total energy globally. India is a tropical country and therefore has tremendous potential for the energy generation through biomass and its residues. Biomass energy is normally obtained from firewood, agricultural residues, crop stocks, animal dung, and waste generated from agro-based industries. In India, biomass energy is being utilized mainly for domestic, commercial and industrial application. The potential in India, except cogeneration, is about 16,000 megawatt. There are various applications that are widely used. Some of them are in following. It is used for the power generation, biomass gasification for the thermal heating and power generation, biogas generation for cooking and distributed power generation. Now we have to understand what are the biomass conversion process or technologies. Biomass is used for the rural domestic energy requirement, that is cooking and water heating. The cooking energy requirement are also made from the cattle dung, leaf biomass from energy plantation and crop residues. In comparison to the fossil fuels, fresh biomass has certain drawbacks which are as follows. First is it has high moisture content that reduces the combustion efficiency. It has low bulk density, lack of homogeneous physical form. Biomass conversion helps to improve the characteristic of the material as a fuel. The conversion process largely involves reduction of the water content and improving the handling characteristic of the material. The energy so obtained can be used for the various applications. In order to extract the energy content, the biomass is subjected to one of the three conversion process that can be used to extract the energy content. First is a physical conversion process, second is biological conversion process, and third is thermal chemical process. Now we have to understand what happens in physical process. The physical process alters the physical state of biomass for improving its fuel characteristic, and some of these methods are given as like particle size reduction, separation, drying, fabrication. In particle size reduction, physical modification like fabrication into pellets help easy storage and transportation. The separation of feedback becomes desirable for using its component for different application. For example, the separation of the agricultural biomass into food component and residues, they may be served as a fuel. And drying also, the drying refers to the removing of all or part of the moisture in the feedback. Open air drying is one of the cheapest method. And last is a fabrication. Manufacturing pellets by extraction technique compact the feedstock, resulting in uniform combustion of the biomass material. Now we have to understand what is a biological process. The biological conversion process are essentially of two types. One is an anaerobic digestion, which is also called biomethanation, and second is fermentation, that is ethanol production. Now third is a thermochemical process. Thermal chemical process refer to the alteration the physical and chemical nature of the biomass through heating. Biomass feed stock has a unique properties that make them ideal for the thermochemical conversion, which convert 85 to 95% of the organic material in the feedstock to liquid and gases with high efficiency. Depending on the condition used, biomass can altered very slightly or be completely changed. Now we have to understand technology used for the biomass based power generation. The technology for generation of electricity from this biomass material is similar to the conventional coal based thermal power generation. The biomass is burnt in the boiler to generate steam, which drives the turbo alternator for the generation of the electricity. And now what is the advantage of this type of generation? The advantage is these plants can be designed to match the electric load, as a biomass can be stored and used according to the demand. and equipment for this plant is similar to that coal-based thermal power plant, and hence no new technological development are required. Due to their proximity to the rural areas, these plants are likely to improve quality of electricity supply there. A variety of biomass material can be used in the same plant, providing the flexibility of operations. Now, the interesting fact is what is a biomass gasification? The biomass gasification is basically thermochemical conversion of solid biomass into a combustible gas mixture, which is also called producer gas, through a partial combustion route with air supply restricted to less than that theoretically required for full combustion. The typical composition of producer gas is as follows. It has carbon monoxide, hydrogen, methane, carbon dioxide, nitrogen, calorific value. The carbon monoxide is nearly about 18 to 20%, and hydrogen is nearly 15 to 20%, methane 1 to 5%, carbon dioxide 9 to 12%, and nitrogen is also 45 to 55%. So here you can see more nitrogen is here, and the calorific value of this gasification is basically 1000 to 1200 kilocalorie per meter cube. That means if 1 meter cubic area of gasification are used, that means it can be generate around 1000 to 1200 kilocalorie thermal energy. Now, need of this gasify biomass. Producer gas can be used as a fuel in place of diesel in suitably designed or adopted internal combustion engine coupled with the generator for electricity generation. Producer gas can replace conventional form of energy such as oil in many heating applications in the industry. The gasification process renders use of biomass relatively clean and acceptable in environmental terms. Large monetary saving can be obtained through this, even partial substitution of the diesel in existing diesel generator set. Now we have to understand how this gasifier work. The gasifier can be of updraft or downdraft types. In the downdraft types of the gasifier, fuel and air moves in a co-current manner. In updraft gasifier, fuel and air move in counter-current manner. However, the basic reaction zones remain the same. This helps in breaking down the heavier hydrocarbon and tars, and these products move downward. They enter the reduction zone where producer gas is formed by the action of carbon dioxide and water vapor on red hot charcoal. This hot and dirty gas is passed through the system of the cooler, cleaner and filter before it is sent to the engine. Now we have to understand what is the application of this producer gas. The clean producer gas can be used for the electrical power generation, either through the dual fuse IC engine where diesel oil is replaced to an extent of 60 to 80%, or through the 100% gas fire spark ignition engine. The producer gas can also be used for the heating to replace conventional form of energy in many applications like small boiler, furnace, hot air generator, dryers, etc. The typical cost of biomass gasifier based electricity generation system range from rupees 4 crore per megawatt to rupees 4.5 crore per megawatt. The cost of power generation depends on cost of biomass, plant load factor, and is estimated to be between rupees 2.5 per unit to rupees 3.5 per unit. That means if you are generating 1 unit of electrical energy, cost will become around rupees 2.5 to 3.5. For thermal application, the capital costs are estimated to be about rupees 0.5 to 0.7 crore for each 1 million kilocalorie capacity. Now next and last topic is biogas. So now we have to understand what is biogas. It mainly comprises of the hydrocarbon which is combustible and can produce heat and energy when burned. Biogas is produced through a biochemical process in which certain types of the bacteria convert the biological waste into useful biogas. Since the useful gas originates from the biological process, it has been termed as biogas. Methane gas is the main constituent of biogas. Now, there are different type of biogas plant, but MNRE has classified different type of biogas plant, which are as follows. First is a fixed dome plant with the brick reinforced molded dome. It is also called Janta model type biogas plant. Second is a floating drum plant with a hemisphere digester. It is also called Pragati model. Third is fixed dome plant with a hemisphere digester. This is called Deen Bandhu model. And fourth is floating drum plant model of the angular steel and plastic foil. It is called Ganesh model. And fifth one is a floating drum plant mode of the prefabricated reinforced concrete compound unit. And sixth type is floating drum plant mode of fiber glass reinforced polyester. And last one is a floating drum plant with a cylinder digester. This is also called KBIC model. Now, biogas plant can also be classified on the basis of the feed. So, how the feed is done, on the basis of that, biogas plant can be classified as batch plant, continuous plant and semi-continuous plant. What happens in the batch plant type of biogas plant? In batch plant are filled with the slurry or waste once and used to take biogas till the material is digested. In continuous plant, which is mostly used, in this type of plant, these are fed continuously and digested material automatically comes out through the overflow wherever new material is filled in. And third is a semi-continuous plant. These are fed once or twice a day and digested material comes out due to the gas pressure and fresh feeding. Now we have to know what are the raw material that are used for the biogas production. So, raw material for the biogas production are the cattle dung that has been recognized as the chief raw material for the biogas plant. Other material that can be used like night soil, poultry litter and agricultural waste can also be used for biogas plant. Here you can see that floating drum biogas plant. Here you can see there is a different unit like gas delivery, gas holder, outlet, inlet, mixing pit. The process of biogas production is anaerobic in nature and takes place in two stages. The two stages have been termed as acid formation state and methane formation stage. In the acid formation stage, the biodegradable complex organic compound present in the waste material are acted upon by a group of acid forming bacteria present in the dung. Since the organic acid are the main product in this stage, it is known as acid forming stage. In the second stage, group of methanoic bacteria act upon the organic acid to produce methane gas. Now another type of biogas plant that is called fixed dome type biogas plant. It has a different unit, that is a mixing tank, inlet pipe, digester, gas holder or gas storage dome, outlet pipe, gas pipeline. Now we have to understand what is the use of all these units. In mixing tank, the feed material is collected in the mixing tank, sufficient water is added and the material is thoroughly mixed till a homogeneous slurry form. In intel pipe, the substrate is discharged into the digester through the inlet pipe. In digester, the slurry is fermented inside the digester and biogas is produced through the bacterial action. In gas holder or gas storage dome, what happens? The biogas collected in the gas holder which holds the gas until the time of consumption. Outlet pipe is used to digested slurry is discharged into the outlet tank either through the outlet pipe or the opening provided in the digester. In the gas pipeline carries the gas to the point of the utilization such as stove or the lamp. Now because you have to install the biogas plant, so it is very important to select the site, how the site will be selected to install the particular biogas plant. So you have to take care the following point: the land should be leveled at the higher elevation than the surrounding to avoid water stagnation. It should be nearer to the intended place of the gas use. It should also be nearer to the cattle shed or the stable for easy handling of the raw material. The water table should not be very high. The plant should get clear sunshine during most part of the day, because why it is important to get the clear sunshine? Because this sunshine will heat the temperature of this celery. If this temperature is more of this slurry, that means fermentation will be more. If fermentation will be more, that means you will be able to get the more gas. The another point should be remembered that plant site should be well ventilated. The minimum distance of 1.5 meters should be kept between the plant and any wall of the foundation. It should be at least 15 meters away from any well used for the drinking water purpose. Now we have to understand how the size of the biogas plant decided. The size of the biogas plant is to be needed based on the availability of the raw material. It is generally said that average cattle yield is about 10 kg dung per day. For example, the average gas production from dung may be taken as 40 liters per kilogram of the fresh dung. The total dung required for production of 3 cubic meter biogas is 3 divided by 0.04, then you can see that is a 75 kilogram. Hence, a minimum of 4 cattle is required to generate the required quantity of cow dung. Now again we can understand how the size of the biogas plant decided. You can understand by the following points. First of all, you must know how much electrical energy do you need for such type of biogas plant. So first of all, you have to calculate the total electrical energy required for your house or for any purpose. And how the electrical energy can be calculated? Because you know the wattage of all the appliances, and you know the timing of the how much time will you use that particular appliances. That means you multiplied by that wattage rating of that particular appliances multiplied by the timing of using of that particular appliances. So it will be watt hour, right? Now you divide by 1000, so it will be in kilowatt hour. That means this is how you can convert number of electrical unit required for in your home. Now you have calculated the total electrical energy required. So I am just taking one example, and I am assuming that total energy required is 50 unit, that is 50 kilowatt hour per day. Right. Now let us now estimate biogas required for the power generation, because you have to generate 50 kilowatt hour, that means 50 unit of electrical energy. So accordingly biogas plant will be designed. So now this electrical energy will be converted into the thermal energy. As you know, 1 kilowatt hour is equal to 3600 kilojoule. So just multiplied this 50 kilowatt hour into 3600, so it comes nearly 180,000 kilojoule per day. And now here I am assuming that generator efficiency of this biogas plant is 80% and thermal efficiency of this biogas engine generator is 25%. So total heat required will come around 900,000 kilojoule per day. Right. Now again we know that calorific value of biogas is 19,730 kilojoule per cubic meter. That means if size of biogas plant is 1 cubic meter, that means it will generate 19,730 kilojoule. Now you have to generate how much kilojoule? 900,000 kilojoule per day. That means you divide this 900,000 divide by 19,730, so it is nearly coming 45.6 cubic meter. So it can be round off. So so it is coming 46 cubic meter. That means if you want to generate 50 unit of electrical energy per day, that means you need to design this biogas plant of 46 cubic meter. Now the total quantity of cow dung required to generate 46 cubic meter biogas plant need to know. Here we are assuming that production of gas per kilogram of fresh dung is 0.06 cubic meter. So just you divide by this. So here this value is coming 766.66 kilogram. That means 766 kilogram cow dung is required to generate 50 unit of electrical energy. Now how will you collect this 76 kilogram cow dung? So that means you need a number of animals. So we are assuming that average dung collection per adult animal per day is 10 kilogram. That means one animal per day give the 10 kilogram of cow dung. That means total number of cattle required is 767 divided by 10. It is coming 76.7, nearly 78. So for generating 50 unit of electrical energy or 50 kilowatt hour, the size of the biogas plant is 46 cubic meter, and total cow dung is required 764 kilogram, and cattle head required 78. So in this lecture we have discussed the solar technology as well as the biomass technology. In solar technology we have discussed the solar cooker, solar air collector, solar water collector, and solar distillation. And biomass, we have discussed the biomass and how the biomass can be used to generate electricity, and how the biogas can be used, and different type of biogas plant has been discussed, and how the biogas plant is designed by taking one simple example. If you have any query, you can shoot the mail at sanjay.agarwal@igno.ac.in. Thank you so much.